Let's see the next question in this exercise, question 10 to 12. A triangle ABC is drawn to circumscribe a circle of radius 4 centimeters such that segment BD and DC, into which BC is divided by the point of contact D, are of length 8 centimeter and 6 centimeter. Let's see the diagram. First of all, the triangle is circumscribed. The circumscribe means outside and inscribe means inside. So a triangle is circumscribed. So triangle is outside. The circle is inscribed. So I will draw the circle completely fitting within the triangle, or in other words, I will draw a triangle such that it barely touches and all the three sides will be tangent to that circle. Now, so that's the meaning of circumscribe versus inscribe. Circumscribe means outside, inscribe means inside. It depends upon which geometry, which shape has been given as circumscribe. In this case, the triangle has been given as circumscribe. So the triangle should be outside and the circle should be inside. Now, this circle is given of radius 4 centimeter. That's given in the question, and it divides the point of tangency, divides the tangent BC as 6 centimeters on one side and 8 centimeters on the other side. Given this information, we are supposed to calculate the lengths AB and AC respectively. Now, this is a tricky question. We are going to approach this using the area calculation. I am going to calculate the area of this triangle using two different methods. One is Heron's formula, which we have studied in 9th grade. If you don't remember, I will quickly revise it, absolutely no problem. And the second, we are going to divide this into 6 right angle triangles and combine that area too. Since it is the same triangle, it doesn't matter whether you follow method 1 or method 2, and we are going to equate that, and that's how we are going to get the unknown side. Let's draw the diagram one more time. I'm going to assume that this is the center, and let's connect that to the 3 vertices, and also let's draw perpendicular lines to the point of tangency. So these 3 lines are connecting to the points of tangencies on AB, BC, and AC respectively, and the dotted lines are just connection of the center to the respective vertices. Now, we know that a tangent connects to the center of any circle. If you draw a line, that would be perpendicular. So these points of contacts, the point of tangencies, are at 90 degrees with the radius lines. Okay. Another thing is, if you consider, now I have color shaded it. Let's say there are 2 brown triangles, and these 2 brown triangles are exactly same, congruent. Why? Because this 90 and this is also 90. So this hypotenuse is the common side, and the radius 4 is same as radius 4. So we can very well show that this smaller brown triangle is same as this smaller brown triangle using RHS in right angle triangle, hypotenuse and side, RHS. Similarly, this small blue triangle will be greenish blue, will be same as this triangle, and this small whatever that color is same as this small triangle. So we can say that if we somehow get the area of this triangle, we will simply multiply by that 2, and this multiply by 2, this multiply by 2. So let's go to the first method, which is Heron's formula. Heron's formula involves calculation of half perimeter, which is the sum of all 3 sides divided by 2. Now, one side we completely know 14, so that's absolutely no problem. But the other side we don't know. Now, if this is 6, this will be also 6 because CPCT, corresponding parts of congruent triangles. But the problem is we do not know this one. So let's assume that this is X and this also X. On the other side, things are somewhat okay. If this is 8, then this is also 8. So that means the entire AB is 6 plus X. Entire AC will be X plus 8. So I'm going to just write down that. So 14 is this side, BC. Then 6 plus x is this side, and x plus 8 or 8 plus x is the AC side. So on simplification, I get 28 plus 2x. I will divide everything by 2 because remember, it's half perimeter, so that divided by 2 is still there. So half perimeter came out to be 14 plus x. Now, the Heron's formula is useful when you know all three sides, and this can be applicable for any triangle. Not necessarily, it doesn't have to be equilateral or isosceles triangle. It doesn't have to be a right angle triangle. So this is extremely helpful when you know the three sides of a triangle. Now you'll say, oh, okay, this is the two sides are still involving x. Okay, we will just keep the x as it is, and we will come up with some expression. Remember, there is one more method we are going to use. So for the time being, s, I will replace it as 14 plus x from here. Now, from 14 plus x, I will subtract this 14. So only x will remain. From 14 plus x, I will subtract this x plus 6. So 6 will remain. And from 14 plus x, I will subtract x plus 8. So 8 will remain. Why? Because the formula is s minus a, s minus b, s minus c. So this is the expression. We cannot do anything further because we don't know the value of x. So this remains as it is. Now remember, this is just one technique. We have used Heron's formula. Now, as per this color combination, we can divide this into 6 right angle triangles, and we can use the formula for area of any triangle. For this purpose, right angle triangle is half times base into height. Let's concentrate on each area. Now this is the complete expression. I have color coded that. Let's focus on the brown area. Why it is multiplied by 2? Because there are two such smaller triangles. Why it is half times 6 times 4? Because we are using the formula half BH, base into height. So for this small triangle, first of all, it's a right angle triangle. The base is 6, height is 4, and half BH. And there are two such triangles. So that's why it is multiplied by 2. Let's use the other color. So let's concentrate on this color. Again, there are two smaller triangles, half base, which is 8, height is 4. So these two are okay. The next one is, now the base is x and the height is 4. So half base into height. And again, there are two such smaller triangles. So this is the area of triangle using half BH formula. There are 6 such triangles, twice of each color, 2 of each color. So we can simplify this expression and we get 56 plus 4x. Now it doesn't matter whether you calculate area using this method or this method, they are both going to be same anyway. So I'm going to combine or equate these two expressions, and that would be my basis for evaluating or finding out the x. So now I have area of the same triangle calculated using two different techniques. I got some expression involving x here. I got some expression involving x here. Both expressions are the same because they represent the same triangle. So now I'm going to equate this with this, which is this expression, and now this will be solved further. Remember, this is where we were at, these two methods. We can say that this is 4x plus 56. I can take 4 common, so x plus 14. Left hand side, I am not doing anything. Now to get rid of that square root sign, I will square both sides. So that would be 4 and then x plus 14. Everything will be square. Here people will make mistake. They will just make x plus 14 square. No, remember, entire right hand side has to be square. So that 4 also will be eventually square. Now this will be 48x and then this bracket as it is. And here we get 4 square is 16, and then we get a plus b square, which is a square plus b square, and twice of their product, 2ab. So that would come out to be 28x. 196 is simply the square of 14, and 4 is also squared, so that will be 16. Now we have to make it simplified as much as possible. This 16 I will get rid of with 48. 48 divided by 16. You have to remember the table of 16 to realize that 16 times 3 is 48. So let's simplify this further. Eventually, I want to make this as a quadratic expression. So I will eventually make that into ax square plus bx plus c equal to 0. So I will multiply this 3x throughout the bracket. 3x times 14 is 42x. 3x times x is 3x square. Now, I will transfer everything on one side so that on the right hand side, I will get simply 0. That will be my quadratic expression. X square comes out to be the other side, becomes minus x square. So 3x square minus x square will become 2x square. 42x minus 28x. Why? Because 28x is transferred to the other side. So that will give me 14x, and this 196 will come to the other side. There is no other constant, so it will become simply negative 196. Let's rearrange that so that it comes into format: square term first, linear term, x term next, and constant term. So now this is in the format of quadratic equation. We can use quadratic equation to solve this one, or you can simply factorize this thing. I would rather prefer to get rid of 2 because this 2 is common in each term. That will simplify, make the numbers a little bit smaller, and that would be even simpler. Now we have to break this 98 in such a way, minus 98, in such a way that the combination of these two factors will come out to be 7. So I'll break that into 14 into minus 7. The product is minus 98, and their sum is positive 7x. From the first two terms, I will take x common. From the next two terms, I will take negative 7 common. X plus 14 is a repeated factor. I will write that only once. And whatever is left over, I will transfer that in one single bracket. That means now either the first bracket is 0 or the second bracket is 0. So that gives me x equal to negative 14 or x equal to 7. Now remember, x represents a partial fraction of that entire side. X is representing a length. It cannot be negative. So I have to discard this negative 14 number and concentrate only on positive 7. So if x is 7, that's the only answer I'm going to concentrate on, because simply the length cannot be negative. Remember, is x your final answer? Technically, no. X is the portion of AB. X is the portion of AC. So now your original question was, what is AB and what is AC? So your entire AB side is x plus 6. X came out to be 7. So that comes out to be 6 plus 7, 13 centimeter. Similarly, what is AC? X plus 8. X came out to be 7. 8 plus 7 is 15 centimeter. So your final answer, AB equal to 13 centimeter, AC equal to 15 centimeter. And that's your final answer, because your question was find the sides of the triangle AB and AC.